All right, guys, so in this video, we're going to go over a few problems from Module 6B homework. Starting with number 1, we're asked to find the GCF of the following list. And in that list, you have 32 and 36. When we are asked to find the GCF, that's the greatest common factor. So we want the biggest factor that 32 and 36 would have in their list. Now, when we say factors, we're asking for digits that can be divided evenly into 32 and 36. Now 32 and 36 are both even, so we know that at least 2 can be divided into both. So let's start with our first digit, 32, and we'll go ahead and take 32 and divide by 2. And when you divide 32 by 2, you get 16. Therefore, we know that 2 and 16 are factors of 32. Now, what else can be divided into 32? Again, it's even, so 3 won't be divided evenly into 32, and we're just going up the list. However, would 4 be able to be divided evenly into 32? And it can be. 4 goes into 32 8 times. Therefore, 4 and 8 would be factors. All right, so we have a pretty good list here, 2, 16, 4, and 8. We've already tried we've eliminated 3. We could eliminate 5 as well, because 5 cannot be divided evenly into 32. However, with 6, divide evenly into 32, and it doesn't. So 6 doesn't go into 32, 7 doesn't, 8 we already have in our list. Does 9 go into 32? No. 10 does not go into 32 evenly. It doesn't divide into 32 evenly. 11, 12 can't be divided evenly into 32. 13, 14 wouldn't divide evenly into 32. So our list looks pretty complete. 2, 16, 4, and 8. Now those are the factors of 32, with the exception of 1, which can be divided evenly into every digit. Now let's look at 36. Now we know that 1 can be divided evenly into 36. However, which of these from our top row could also be divided evenly into 32? 36. So we know 2 can divide evenly into 36 because 36 is an even number. And it's 18 times that 36 is divided by 18. So 2 and 18 would be factors. And we check out 16. Can 16 be divided evenly into 36? We're just checking all the numbers from our first row. And 16 does not divide evenly into 36. Does 4? Can we divide 4 into 36 evenly? And we can. 4 can be divided into 36 9 times. So 4 and 9 would be factors. Let's see, what are we missing? 10, 11 would not be able to be divided evenly into 36, but 12 can divide evenly into 36 3 times. So 3 and 12 will work. We missed our 6 as well. 36 can be divided evenly by 6. So 6 would be a factor. Now let's stop there because we're really just trying to find the greatest common factor, the factor that is shared between the list for 32 and the list for 36. And the greatest common factor that we see is 4. So that's going to be our GCF. Looking at number 3. Now what do we do when we're asked to find the GCF of variables? What we do is we find the highest shared number of variables. What do I mean by that? So our first term is y to the 7th power. Essentially what that means is 7 letter y's. I have y times y times y times y times itself 7 times. Y to the 5th power means I have 5 y's, and y to the 4th power means I have 4 y's. Now what's the highest number of y's that I could take from each of these terms? I could take 7 y's from the first term, but I could only take 5 from the second one. And then I could only take 4 from the third term. But what's the highest number I can take from each? It's 4. So I could take at least 4 y's from each of these terms. That's my greatest common factor. It will be y to the fourth power. Now looking at number 6, factoring the negative number or a GCF with a negative coefficient. Remember, that's the number that's in front of the variable from the polynomial. So in this polynomial, we have negative 5x, let's recopy that on the side, minus 15. And we're asked to factor out our GCF. And we're looking at two terms here, negative 5x and negative 5. Now I have two integers that are both negative. I want to find the greatest common factor. What's the biggest number that I can divide into both 5 and 15? And that will be 5. I can also factor out that negative symbol because they both share a negative. So I can factor out negative 5. And when you factor your negative 5 from 5x minus 15, we want to write what's left. All right, it's important that you pay attention to the terms. All right, look at our first term that we started with. It was negative 5x. If we factor out negative 5, what's left? That position that's in the front of or right behind your negative 5, but in your parentheses, you replace, hey, what do I multiply negative 5 by to get negative 5x? And it's x. In the second position, we're asking ourselves, what do I multiply negative 5 by to get negative 15? What do we multiply 5 by to get 15? And that's 3. It will be a positive 3. Why? Because we already factored out the negative. Now, how do you know you factored correctly? You can check your work by simply distributing. All right, so this would be your solution. Negative 5 outside parentheses and inside x plus 3. But if you want to check your work and make sure you did it right, you have negative 5 times x, that'll be negative 5x. And then negative 5 times 3, that'll be minus 15. If you get what you started with, like we did just here, then you know you did it right. You know you factored correctly. Let's look at number 9. We're factoring out the GCF from this polynomial. Now you'll notice in this polynomial that you already have parentheses and numbers outside parentheses. So to get your GCF, all right, one of your GCFs, you're going to have two terms in parentheses that you're looking at here. So the term that's shared, the x minus 7, notice you have two of those shared terms. That's going to be one of your factors. X minus 7 is going to be one of your factors of your solution. Now the next solution will come from the two terms that are outside parentheses. We have y outside of the first parentheses. That'll go inside our parentheses. And then we have plus 9 that's outside the second set of parentheses. So plus 9 would be our second factor. This will be your solution. X minus 7 and y plus 9. Let's look at number 12. We're factoring this 4-term polynomial by grouping. So this method of grouping, you want to start by first attempting to group together the first two terms. So that means just put parentheses around the first two terms, and then group together the second two terms by putting parentheses around them. After you group them together, you want to factor out the GCF of both of those two terms, two sets that you placed in parentheses. But let's look at the first set of parentheses. We have 8x plus 16. And in the second set of parentheses, we have xy plus 2y. We want to factor the GCF from both of these parentheses. So from 8x and 16, what's our GCF? What can I divide evenly? The highest number I can divide evenly into 8 and 16 is 8. So that's what I factor. If I factor out 8 from 8x from my first term, what do I multiply 8 by to get that 8x? X. Plus, what do I multiply 8 by to get 16? That's 2. So there's your first set. We factored our GCF. We're going to take those same steps with the second term. Now look at our second term. We have xy plus 2y. What term do each of these share? And that's y. So we can factor out the letter y from the first term, and if I factor y from xy, what's left? It's x. Plus, if I factor y from 2y, what's left? It's 2. Now notice we have the same term in parentheses, x plus 2 here and x plus 2 here. When you see that shared factor, you know that you've done your work correct, meaning you grouped together the right combination. So our first term would be x plus 2 in parentheses. That's one of our factors. And then the second factor is going to be the terms that are outside parentheses. So 8 plus y. And that's your solution. Now, when you write your terms in parentheses, your order doesn't have to be as you see here. Like if you put x plus 2 as the second term, that would be okay for you to place the 8 plus y in front. So these order could be changed. It doesn't have to be in the same space or the same order that I placed my solutions. Let's move down to number 15. So we're factoring this 4-term polynomial by grouping again. So we're grouping. We're going to attempt to group together the first 2 terms, just like we did before, and the last 2 terms. So I'm placing parentheses around the first 2 terms, parentheses around the second 2 terms. I'm going to recopy them here, and then we're going to factor. So the first set of parentheses, we got 9q squared minus 8pq. All right. Now from these 2 terms, 9q squared minus 8pq, we want to find our GCF. Now between 9 and 8, there isn't a number other than 1 that we could divide evenly into 9 and 8. However, I see q squared, meaning I have 2 q's with my first term, and I see 8pq for the second term. So I have 1 q that I can factor from both terms. So I'll factor q from 9q squared, and what's left, it will be 9q minus. Now I'm factoring out a q here. I know that might look like a 9, but this is the letter q. So q from 8pq leaves 8p because we factored the q outside the parentheses. So I have q outside parentheses, 9q minus 8p inside the parentheses. Now this is just the first term. We still need to factor the second one. Remember, it was negative 9q plus 8p. And we want to attempt to factor a GCF from negative 9q and 8p. And if you notice here, there isn't a term that I can't factor other than 1, because these 2 terms don't share a letter, and there's no number other than 1 that can be divided evenly into 9 and 8. Now, what does this mean? That we have to go back to our groups. It means that when we factor by grouping, we cannot group together the first 2 terms and the second 2 terms, because, as we just noticed, we don't have a GCF when we combine the second and third term. Now we have to clear this out, and we're going to try to group together a different set of terms. So instead of grouping together the first 2 terms and the last 2 terms, we're going to group together the first term and the third term, and then we'll group together the second term and the fourth term. So we're going to mix up our combination and place parentheses around these 2 terms. So I have 9q squared in parentheses, 9q squared minus 9q. It's going to be the second term that I attempt to group. And then the second pair would be in parentheses, negative 8pq plus 8p in parentheses. Now let's attempt to factor our GCF from both of these terms and see what we come up with. So we have 9q squared minus 9q. What is our GCF? Now look, both of these terms have 9, so we can factor out a 9. But also both these terms have q, so I can factor out at least one q. When I factor 1q from 9q squared, I have just 1q left. So we factored out one of the q's and we have an additional q that's left. We factored out 9, so 9 is already outside of parentheses. Minus, when I factor 9q from 9q, what's left? Just 1. So we're really asking ourselves, what do I multiply 9q by to get 9q squared? And that's how we get the q. What do I multiply 9q by to get 9q? And it's 1. So this is our first factorization. Let's find our GCF between the second two terms. Negative 8pq plus 8p. Again, I have a shared integer. I can factor out the 8. Now we'll have to determine whether or not we should be factoring out a negative symbol or not. Really just basing it on what we already see in our first factorization. See how we already have q minus 1. So we want to make sure that we also have a minus inside the second set of parentheses. So if I factor out a positive 8 from 8pq, right? Is there any other term that I can factor from both? And I can factor p from both these terms. So in my parentheses, I'm also going to factor out, or outside our parentheses, we're also going to factor out the letter p. So 8p outside parentheses, open your parentheses, and now you're asking yourself, what do I multiply 8p by to get 8pq? And what's missing there is the q, but also the minus sign. Now we already know from our first factorization that our q should be positive, so I'm just going to attach that negative outside the parentheses. All right, because a negative times a positive is how we're going to wind up with the negative that we started with. So negative 8p will factor negative sign outside parentheses. What do I multiply 8p by to get 8pq? And it's q. What do I multiply 8p by to get positive 8p? Now, how do I get a positive when I start with a negative? I would have to make this a negative sign. Remember, a negative times a negative is what will produce the positive symbol. And what do I multiply 8p by to get 8p? That's just 1. Bingo, we have the right factorization, okay? If we wind up with the shared factor, in this case it's q minus 1, then we know we factored it correctly. Now, how do we write our solutions from this stage? The shared factors. So the q minus 1, that's going to be one of our solutions. Q minus 1 in parentheses. And then the second factor will come from the terms that are outside parentheses. So 9q, and it's a minus sign in front of the 8p. Close your parentheses. This would be your solution. 9q minus 8p in parentheses and q minus 1. Let's look at number 25. We're factoring this trinomial completely, and if the trinomial contains the greatest common factor, that means that our leading coefficient, like in this case, if it's anything other than 1, then we need to factor out the GCF. All right? And don't forget to factor this first. So that's what we're going to do first. Look for a GCF. Is there a term that we can divide into 3x to the 4th power, negative 39x squared, and positive 120? And it is. We know we can factor at least 3. So we're going to factor each term by 3. And the x term is not shared between each of these terms, therefore we wouldn't factor out the x. We're just going to factor 3 from all 3 terms. We'll do that first. So we're taking each term and just factoring out a 3. I'm going to place 3, and then I'm going to open parentheses. And we're asking ourselves, hey, what do I multiply 3 by to get 3x to the 4th? If I factor out 3, what's left is just x to the 4th. All right, and then you ask yourself, hey, what do I multiply 39 by to get, I just gave you the solution, didn't I? So what do I multiply 3 by to get 39? And that will be minus 13x to the second power plus, what do we multiply 3 by to get 120? All right, to get all of these numbers that we're speaking of, you would just divide 3 into each of these terms. So 39 divided by 3 is how we got 13. 120 divided by 3 will give us 40. All right, so now we factored our GCF of 3. We're going to keep 3 outside the parentheses. Now, at this stage, we have a trinomial in these parentheses. That trinomial can be factored. So I'm going to open 2 sets of parentheses. The way you factor trinomials, if you have 3 terms, is you find 2 terms that multiply together to produce your first term. In this case, it's x to the 4th. So we want to find the 2 factors that multiply together to give us x to the 4th power. And they are x to the 2nd power and x to the 2nd power. So x to the 2nd power times x to the 2nd power is how we get x to the 4th power. Now our 40. We want to find 2 factors of 40. So we want 2 numbers that multiply together to give us 40. But not only do we find a combination that multiplies to give us 40, it must also have a sum of our middle term. So it has to have a sum of 13. Now I recommend you start a list, maybe on the side. I'm just going to rewrite 40, and we're going to list 2 numbers, sets of pairs that multiply together to give us 40. So 10 times 4 would be one example, because 10 times 4 gives us 40. But I must also find the combination where when I add them together, my sum must be negative 13, okay? Now, because our sum is negative 13 and our end term is positive 40, I know I have to have 2 negative numbers. Because when I multiply 2 negative numbers together, I'll get positive 40. But if I add them, I'll get a negative number. And negative 10 plus negative 4 has a sum of negative 14. That's not negative 13. That's not the pair we want. Let's find 2 other factors that multiply together to give us 40. So 8 times 5 will be a pair, right? 8 times 5, and we want both of these terms to be negative. Negative 8 times negative 5 gives us positive 40. Now let's check the addition. If I add negative 8 plus negative 5, will I get negative 13? And you do. So this is the combination we want. We have a minus in front of the 8 and a minus in front of the 5. We just list those right next to our x squared. So minus 8 in one set of parentheses, minus 5 in the other. And that's it. Those are our factors. Now remember the 3 that we factored out at the beginning? We're going to just carry that down. So our final answer would be 3 outside parentheses, and then x squared minus 8. Close the first set of parentheses, open the second set, you get x squared minus 5. All right, so those are our factors. And that's the end of our homework examples for Module 6B.